Were you guys able to check out the recordings? Posted the recording from last class. If not, it's there, I promise. All right, you just hit the link, go to YouTube, find me, and there it is. So we are recording. Oh, know what I forgot to do. So, show you guys around on Moodle here. Oh. What the? Okay. Just asks for stuff and then changes its mind. Anyways, so here's all that information that we talked about last day. And the test dates, I made a designated WebAssign section on here, right, with all your login information. Remember, you get the 14-day free trial to try it out, and then or if you want to just go out and buy the access code. So we will be using WebAssign for the assignments, and then to log in, whether it's the first time that you log in and you have to enroll with the class key, right? We talked about that last day. There's the class key. You hit this, or if you're just going to do your assignment, you hit the login link. You can probably save it, and you'll know where it is. And then there's the slides that we went through last day.
Give me a 12-day trial.
I suspect, after playing around with it, I think it's from the course start date that you got the 14 days. So
yeah, I just signed up last time. That 12 days.
I think, yeah, I think they're just like, well, the course started here, so. But I wonder if I can maybe schmooze them a little bit and tell them, oh, I didn't actually get a chance to, and extend it a little bit, right? But we will be using it, so so we'll buy the access code. But if you go there and then you log in, sign in. This is assuming you've enrolled. I've got my 2 classes here, and if I go, what if I open student view here? Because mine looks not as good as your end. Mine looks all old school and nasty. Right? So here, this is where all your assignments will be. I posted, just to show you guys, right, some pre-lecture assignment, quiz, whatever you want to call it. And so the idea being that you would go through and do these just to make sure that you've got the concepts that we're about to go through down. And it's really fine if, you know, if it's not making sense, but then at least if you work through some problems before you come to class, then you'll have better questions to ask me, right? And by better, I mean more specific questions, not just, how do I do section 1.2? Well, section 1.2 is a lot of stuff, right? And you probably know some of it, right? But you want to really focus in on how can I do this question, for example. So once you sign in, then it gives you all these resources, and one of which I'm assuming, yeah, is the textbook. So here's where you can access the ebook. So, but anyways, going back to my view, I see 4 students are in here already. So nice work. We'll get everyone in there. May as well go in for the free trial at least, right? Just check it out. And I think what you'll find is that those questions that you're working through will be a lot more helpful than if you were to do it by hand, for example, right? So that's why I'm pushing you in this direction, so that you have all those resources and all that fun stuff. Okay. And you do get the ebooks, so pretty good. All right.
How do we look at the I think, let's see here. Take me back to student view. Oh, I think it complains because you have to be in the browser, but I guess I'll be in the browser here. Let's have a look. Resources. What happens if I just press it and hit this one? Well, lecture outline, lecture videos. Oh, weird. That is not what I thought was going to be here. If I go to the, oh, this looks better, doesn't it? Oh, I just assumed it was going to be there. Sorry. How do you? My ebooks?
Maybe.
I did that, but then
Try
it took
that.
me back to where you just were. With
Ooh.
the places and stuff.
Communication. Oh. What if I click Mind Tap? So I scroll down to the very bottom, and this feels promising. Yeah. Okay. I was finding that it was pretty sluggish, at least to like open up. It's a huge textbook.
I mean, we're definitely not going to go through all of it, and this is the instructor's edition, but it's pretty big, right? So you don't need to buy the hard copy. You can make do with the ebook if you want to.
If you want both, there's, I still have to check. I forgot to check last day, but there should be copies in the library that you can take out and kind of use for the day, right? They might be on reserve, so then you go to that desk, I think, and get them from the reserve. But so from here, yeah, there, a little bit roundabout, actually really roundabout. So I just scrolled way down to the bottom of the page, and then this link took me there.
And it sounds like the 14-day trial started from this date, but I'll send an email and see if I can kind of schmooze her and say, well, I only just told them about it today. Okay, let's see if we can change it.
Yeah. It only buys us a few days, but still. All right. Yeah, any other questions about that? So go check that out, see how it goes, and let me know. I am special, so I have a secret PDF version, which is a lot easier to navigate, I find. So anyways, but the online one should work out just fine. All right. Oh, that's what I wanted to do. I was on Moodle. Take me back to Moodle.
So here, right, I posted our course outline, which we kind of went through last day.
And then you'll notice that after each class, I just post the notes that whatever I write on the board, right? I'll post those after class. Yeah? So we didn't write a lot last day. Today we'll write a little bit more. Okay? But then I also posted, last night I posted this chapter 1, and this is the handout that I brought for you.
It doesn't look like anyone's working on a tablet, but if you prefer to just work on a tablet, that's totally fine, right? Just let me know and I'll stop printing copies for you. Right, save a little bit of paper, but otherwise for these notes, because it's going to be a little bit of printing, I'll just print them for you and I'll bring them to class. And so you'll get them, don't worry about it. But they are there if you want to have them just kind of online. Okay?
So this one is what I want to go here, create a new note. I work in Notability, but I'm thinking about switching to OneNote. Has anyone used either of them? OneNote's pretty good. I know. I saw that they were making a bunch of updates, so I think should be pretty decent now. But and you get OneNote and stuff for free with the college, anyways. You guys know that you get Office 365 or 360. Both of them work, and so that's why I'm always confused. Which one? I think it's 365, right? So you get all those for free through the college. Well, for free.
Did you get that from the library?
It's through IT, and I would just go ask them about it. Just be like, I'm hearing rumors that I can get it for free, but how?
We just,
Yeah.
we just open like sign into your WebAssign and pop up.
I have done it, but it was a long time ago. Anyways, cool. Yeah. So sounds like my Okanagan is the place to go. Cool. All right. So we're gonna start, well, you hate to say from the bottom, but we're gonna start from the top and kind of work our way into the nitty-gritty of math, right? And so here in chapter 1 especially, we're just going to talk about the foundations of the rules or the laws of math, right? Because by the end of this course, I want you to be able to identify illegal math, right? Bad math, because there are rules that we need to follow. And so this chapter especially will just help us establish what these rules are. And what you'll find is that it's just going to be a matter of just memorizing those rules, right? Knowing how to use those rules and just following those rules. It's like learning to play a new game, right? And it is just a game, right? It's learning to play a new game. You need to know the rules. So that's what we're doing here. And then you just play it. And those are the exercises that you're doing, right? And so if you think about it that way, right? If you're doing an exercise and you're saying, hey, I don't know if I can do that, right? Then all the information that you'll need will be in these handouts, right? They're pretty sparse because it's just the information that you need. So there's not very much writing. There's writing in the beginning. And then I wrote up a little blurb on the sets and intervals. Right? But other than that, and then at the end, rationalizing the denominator. So I write up little blurbs if we need them, but otherwise this is like a condensed version of the textbook. But they are stolen from the textbook. So if you want more talking around one of these things that we're about to talk about, for example, if you want more talk about this, then you can just go find that in the textbook and kind of read around it, right? Because like I said, these are just stolen from the textbook. Yeah. So first thing that we want to do, I'm going to start. I'm going to steal this and start a new note, a fresh note here. How about that? Yeah. And so what I'll do is I'll kind of pull all the information that we need into this note, right? And this is the one that I'll post on Moodle after class. Yeah. So let's talk about numbers. I know it sounds silly to talk about numbers, right? But we do need to have a lot more vocabulary than just calling them numbers and then being done with it, right? Because there are a few different types of numbers that we could have, right? And so the numbers that we know, so every single number from negative infinity to positive infinity that you could possibly think of would be considered a real number. And as silly as it sounds, right? There are real numbers, and then there are imaginary numbers where we're taking the square root of -1. It puts us into the imaginary numbers.
we're not going there. Don't worry, right? That's like upper level math stuff. So we don't have to deal with that, right? But just know that there are real numbers and then there are imaginary numbers, and it's fun to think of, but for us, we only need to deal with real numbers. Okay? And so the set of real numbers can be broken down into different categories. Okay? The most basic is the natural numbers. Okay? The natural numbers, if I ask you to start counting, 1, 2, 3, 4, right? So I think of it, okay, those are the ones that naturally come to mind. And so for notation, I'll zoom in a little bit here. Oh, maybe not. How can I? Oh, I didn't want to do that. How can I zoom? Oh, there we go. The set of real numbers is this fancy R, right? And so here, all right. Oh. If I'm writing it by hand, oh, that was a really bad example. I write it with, I write an R with a double back, right? Because you can't do those fancy R's, right? It's fine if we're typing, but if we're writing and I want to talk about the set of real numbers, right? So any number that we can think of, then I summarize it with this capital R with just a double back. Okay. Same thing for the set of natural numbers. I just do an N. Oh, I do an N with another kind of with a double back again. Not too picky. All right. Z, I do also with a double back. You're seeing the trend, right? So for all these that I've written out, so the natural numbers are, and I just remember it as, okay, if I had to start counting right now, naturally I would start at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't go 1, 1.5, 2, 2.5, 3, right? I don't do that. So there are some things that we can only do with natural numbers, right? And so that's why we need to be able to specify. If we want to broaden it a little bit, right? Maybe include some negatives in there, but still working with whole numbers, then we can talk about the set of integers. Integers are confusingly denoted by the Z, right? And so the set of integers, and the background reason for that is because I is reserved for something else. Okay? And so they said, oh, well, let's use Z. Sure, got it. So the set of integers occurs quite frequently, and that's when we have whole numbers still, but we can go from negative infinity by whole numbers, including 0, right? And then into positive numbers all the way up to positive infinity. One thing to keep in mind is that infinity on either end is just an idea, right? It's not actually a number. It's just because it just keeps going and going and going and going, right? And so infinity is this idea. It's not actually a number. Questions so far? Oh. Numbers got a pretty good handle on so far, right? We can talk about rational numbers. Rational numbers is just a ratio, so a fraction. Okay. And so here, all right, R equals M over N is a ratio of integers, right? Where M, so a ratio
is a fraction, right? We've got a couple of different terms for this thing, right? But if we're dividing one thing by another thing, we've got a ratio or a fraction, or can you guys think of some other? I don't know. Yeah, division, right? And so I hear you're trying to say one, but I can't hear it. It's okay. And so fraction or division, right? All of those things just means you're dividing one thing by another. In fact, the terms is the numerator is the thing on the top, right? So a fraction is the numerator divided by a denominator. And what you'll probably find with a lot of these things is you'll have to kind of make up little things to help you remember these in the beginning, right? And so how I remember it is, well, the numerator is on top because it's numero uno. So it's on top of all everything else, right? And then as long as you can remember one, you can remember the other, right? And so everything else is in the denominator. So just being fluent with talking about the numerator, talking about the denominator is pretty important in this course. So rational numbers can be reduced to some fraction, right? So an integer over an integer. So 45 divided by 3, for example, right? That's an integer over an integer. Negative 45 over 3 is still allowed, right? You probably remember that one of the main rules of math is that we cannot divide by 0, right? So division by 0 just can't happen. You can try it on your calculator and it's going to say error, right? It just won't be able to do it because we cannot divide by 0. And so here's a rule. We cannot divide by 0, right? And this is going to be important later on when we start talking about things like the domain of a function and just stuff like that, right? Keeping in mind that, okay, if I'm trying to divide by 0, something bad is going on here, right? And for that reason, a lot of the time, there will be added little things here, right? Because n is in the denominator, right? And so where m and n are integers, fine, and n is not equal to 0, right? So one of the assumptions that we're applying here is that we're not dividing by 0, right? So everything else goes. And so moving on to irrational numbers are kind of those nasty numbers where we've got repeating decimals or never-ending decimals, like pi, right? Pi keeps going and going and going and going and going, and it never repeats, right? And so all those would be irrational numbers. And so any number, even a number like 1 over 2, right, 0.5, can be written as a decimal, right? So any number can be written as a decimal. And so I think I forgot my calculator. How funny is that? Teaching a math class and I forgot my calculator. Must be the beginning of the term. That's all right. All right. But what you can do later is you can go through and do things like 157 over 495. I guess I've got it. Maybe I've got it on here. There's no calculator. Does the iPad not have a calculator? Oh. Weird. Oh well. How about you guys do it and you tell me what it is? How about them apples? 157 over 495. I can do it on my phone. Mm-hmm. I'm going to go with 0.3171717. And the only reason that it probably rounded to 2 is because it's saying, hey, it just keeps going 17171717. So how we should write this is 0.3, and then it looks like it just keeps repeating 171717. And so what we do is 17, and then we put a bar over it to show that it's repeating. Repeating. Or usually what we end up doing, right, almost automatically, is we just round it, right? My main concern is going to be that it's really important to show that you've rounded it, right? Because the exact number is 0.317 repeating, right? If we round this to 0.32, right, that's an approximation, right? And so it's going to be important to differentiate between the actual number and an approximation. And so what we do is we use this squiggly equal sign. Oh, that was a bad one. Also a bad one. There. Right. To say it's approximately equal to 0.32. Approximately. Oops. Equal to. Yeah. So I want you to start paying attention to things like that, right? Because being able to say, well, this is an approximation, right? It's not the exact value. And saying, no, this is the exact value, right? Because we get different results depending on how we've rounded, right? We rounded to 2 decimal places, we could have gone to 3 decimal places, 4 decimal places, right? It doesn't matter. But as long as we show that it's an approximation, right? So try to get in the habit of just using the squiggly equals if you've done any rounding. All right, so right off the bat, math is all about rules, right? I make it all stern, but it's really just a game, right? And so in general, try to stack your equal signs, right? And so it just makes your work more clear and it just looks better, right? So if you're going equals, 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 it's a real mess, right? For stuff like this, when we're showing our work, right, I would way rather that you just use up a bunch of paper. You're just writing it anyways, right? We're not printing. So pretty low cost, right? Except to the environment, I guess. No, the difference is minimal. So instead of writing equals, 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 equals across your page, right, I want you to, as much as you can, and there are times where even I can't quite bring myself to do. So sometimes I'll go across the page, but more often than not, I'm just going to try to start here, put this equal sign, and then line them up as best as I can. And in that way, if you keep going in calculus, your instructor is going to be so impressed and pleased. Okay. So, any questions about that so far? So for example, if we write pi, right, you can calculate pi on your calculator. It's going to stop after 9 digits or so, depending on the strength of your calculator. That doesn't mean that pi ends there. It just means that our approximation ends there, right? And so for things like that, we have to use the squiggly equals. Okay. Okay. Not now. Okay. Let's see here. Any questions before we go on to the properties of real numbers? So these are all the numbers that we just talked about, all right? So all these properties are things that you already know. But what might be different is you might not have seen them written in terms of variables, right? If I tell you, or ask you rather, is 3.1 the same as, or 3 plus 1 the same as 1 plus 3? You would say yes, right? 3 plus 1 is 4, and 1 plus 3 is 4, right? So they're the same. The reason for that is because in general, we can write A plus B, regardless of what they are, is the same as B plus A. So for addition and multiplication, that's true. Order does not matter. And so it doesn't matter, but that's only for addition and multiplication, right? If you're dividing, which one you're dividing by which, it matters, right? And same thing, 3 minus 1 is not the same as 1 minus 3, right? So it doesn't work. But those are called the commutative properties. And the associative properties say that, okay, well, we can wrap brackets around addition and multiplication, but again, the brackets don't really matter. The brackets are going to matter when we start combining things, right? Remember BEDMAS? Probably. Brackets, exponents, division, multiplication, addition, subtraction. So that's when brackets come into play. But if we're only talking about addition, or only talking about multiplication, order doesn't matter. The distributive property is, well, we've got A times B plus C. So this is a combination of, we've got A is multiplying B plus C. So this is one of those times where, okay, well, now I've got multiplication and addition in here. Right? And so what you want to keep in mind is that this A is multiplying each individual term that's inside these brackets, right? And so this A is going to get brought into the B and the C. So if I do that, then I get A times B. So we can write that as AB. Usually I don't bother with the multiplier, right? If you like to use an X or a little dot. But if we're just multiplying variables especially, then I just skip those, right? AB is the same as A times B. And then plus AC, because it's A times C. Same thing happens if the multiplier is on the other side, right? We can pull the A out to either side, or it can be from either side, but either way, it's going to hop back on to each term inside the brackets. Any questions about that? Let's talk about negatives. So sometimes there are little examples in the margins, and that might be helpful. So for negatives, if we've got a -1 times A, we can just rewrite that as -1 times A is just -A, right? And so that -1, we're just multiplying it by A, and so it disappears. If you're taking the negative times a negative, right, for the negative of a negative number, it becomes a positive, right? So 2 negatives make a positive, and so that's how that's shown in general. -A times B
is the same as a times negative b, right? If one of them is negative and the other one is positive, then we get negative a times b. Again, if you're multiplying two negatives, then those combine to make the positive version of it.
And then same idea. Oh, I guess.
This negative outside, so this is going to be pretty common, right? And we need to keep an eye out for it. Is anyone in the business program? No? Anyways, those guys have a heck of a time in business math because they always forget to bring the negative into both terms on here, right? So they'll bring the negative on the A, but then they forget to bring the negative on the B. So you want to learn from that, right? And say, okay, well, I have to bring it just like we did here, right? That negative has to go on each of the terms. Especially if you're talking about money, it makes a big difference. Adding when you should have been subtracting. And then same idea here. I'll just scroll up a little bit. If you've got a negative on the outside, right? Negative times A is negative A, right? But then negative times minus B, right? Or negative B. Well, then we get negative A plus B, right? And they've just rearranged the order to be B minus A. But for this one, oops, I'll say, okay, well, negative A minus B is the same as negative A minus negative B, which if we combine those rules above, then we get negative A plus B. And then they've rearranged it as B minus A. I think they just like to do that. For me, I would probably just stop here. I think they just don't like starting with a negative number. So then they switcheroo those. Okay. Any questions about that so far? No? Okay. So I'm gonna steal some problems here. Post them in, paste them in here. I guess I should have given you what to do first. Where did I steal that one from? Here. Sorry, I just thought to do this before class, so that's why it's not prepared yet, but that's okay. Here we are. So if you see something like this, right? First of all, I want you to try to just do this and make sure that you get to the same result. Right? But also, from that list of properties, the commutative property, the associative property, the distributive property, right? Which one have we used here? Top notch, right? Because what we're doing is we've said, well, from 5x plus 1, they've thrown an x in there, right? 5x is just 5 times x. X can be anything, right? And so we just treat it as one thing. 5x plus 1 times 3, well, we said, well, I have to bring the 3 onto here and the 3 onto here. So this becomes 3 times 5x. Notice how I'm using those brackets just to show that I want to use 5x as one thing. And then plus 3 times 1.
just to indicate that I'm multiplying these two numbers. 3 times 5 times x, well, 3 times 5 is 15. Oops. So we get 15x plus 3 times 1 is 3. And so this, we said, was the distributive property. And because there's a page break here, I'll move this down. Okay. Just steal the whole question this time, might be easier. So there will be more to do, but for now, let's do 23. So what it's asking us to do is just to expand this using the appropriate rule that we learned. So again, it's going to be that distributive property. Perfect. So if we've got 3 times x plus y, well, that becomes 3x plus 3y, and then we're done. What if we had to do something crazy like 28? You'll be able to do all of these, right? But right, or seemingly hardest one, right? So this was 23. What if we had to look at 28? So I want you to just take 2 minutes, try it. I'll write it out here. So even though there's more than 2 terms inside the brackets or the second set of brackets, that's okay. We can just keep going, right? And so this 3a gets multiplied onto each of these 3 terms. So we've got, so how I'm going to write it, just to be careful, I'm going to do 3a times b, and then plus 3a times c, and minus, that's good if you're being careful. But what I probably would do, just to recommend, if you went straight for the minus, then that's really good. But to keep the same, see here, I ran out of room, plus, I'll do the 3a times negative 2d, right? Because then I can do plus, 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 right? And then just keep that 2d negative for when I multiply it, right? This plus is going to go away because we know from which property, the associative property, or later on, property 4 of negatives, right? Maybe it's 3. It's 3. But either way, this becomes a negative number, and so that plus turns into a minus. And so we get 3ab plus 3ac plus, and then negative 6ad, which becomes 3ab plus 3ac minus 6ad. So hopefully all this is feeling pretty good. All right. Then let's talk about fractions and properties of fractions. Oh. For fractions, right, and we talked about fractions, some ratio, division, right, we've got fractions. They're going to behave a little bit differently depending on if we're multiplying, dividing, adding, or subtracting, right? And so the reason they start with multiplying fractions is it's actually the easiest one to do. Right? So what you'll see from here, right, is that if you're multiplying two fractions, regardless of what the denominators are, right, we just multiply across and multiply across, right, to get our answer. So multiplying fractions is going to be the easiest thing that we can do. Right. What if we have something like this one here? If we've got A over B divided by C over D, you can rewrite this as, oops. A over B divided by C over D. I like to, if I'm doing a fraction over a fraction, right, I like to make my central line nice and big so I can keep track of which one's which, right? Clean up this B here. Oops. Didn't help that much, right? So what happens is it becomes A over B, that's the same, right? But then now we're multiplying, so we went from division to multiplication and put D over C instead, right? So that's why I like to write them out like this, because what happens is you take these two, you flip them, and then you multiply them on the top. And that's how you do it, right? So there's a couple of different sayings, right? I like flip and kiss. So then when you're kissing, you're multiplying, right? And so here, you're gonna flip these and multiply them. Right? I guess you could just say flip and multiply, but that's too boring. So this becomes A over B times D over C. Flip and multiply. Or kiss, depending on which one you prefer. I think that's the only time we'll refer to multiplication as kissing, though. So if we move on to adding fractions, right? A over C plus B over C. Now, as soon as you get into adding or subtracting fractions, you need to double check that this denominator is the same as this denominator, right? In this case, C is the same as C. So then we can just go ahead and add those numerators, right? And put it over the same denominator. So you don't add the denominator, it just stays the same. Okay. If the denominator is not the same, right, B and D, then the easiest thing to do is just to multiply this side. I think I'm gonna sit down. I'm not used to standing so much, I think. Getting a little lightheaded up. Usually love to stand. Thanks. So if we have different denominators, like here, I'll put a little 4 here. then we're saying, okay, well, I want to add A over B plus C over D. To get the same denominator, what I'm going to do, and this usually throws a lot of people for a loop, is I'm going to multiply this side by D over D. If I say, what's 2 divided by 2? You'd say 1, right? D divided by D, 1, right? So that trick of multiplying by 1, a convenient 1, is something that we're going to do all the time, right? Whether you want to cancel something or you want to get a common denominator, that's going to be pretty common. Right, so here, what I'm going to do is I'm going to multiply A over B. I'm going to multiply it by D over D. Because this is just 1. Right? It is just 1. D over D is 1. So I'm multiplying by 1. So I'm not actually changing anything. Right? And that's the key. Plus C over D. But now I'm over D and I want to have it over a combination of B and D, right? And so now I'm going to take this other denominator and I'm going to turn it into 1 and put it over here, right? So what I end up doing is I do times B over B, right? Which is also 1. Because we know how to multiply fractions, right? We can just multiply straight across. And so what we get here is we get A times D, AD, over B times D, plus C times B, over D times B. D times B and B times D, that's the same value, right? So now we have the common denominator. We now have a common denominator. Woohoo. Okay. So now that we have that common denominator, now we know that we can just add the tops and keep the denominator the same as the common denominator, and then we're done. So we get AD plus CB on the top in the numerator over BD or DB, it doesn't matter. And so that's where the jump from here to here came from. If you've got something like this, I guess I should scroll up. AC over BC, you're allowed to cancel these C's because you're multiplying, right? If you're adding, so if you've got A plus C over B plus C, you cannot cancel those. You're only allowed to cancel if you're multiplying. Number 5. We can only cancel if we are multiplying. Right. So AC over BC, those C's can cancel and get you A over B. Oops. But for example, A plus C over even C, you can cancel it on the one side, right? but you can't cancel it on the other side, is A over C plus C over C. You can split it up like that, kind of do reverse fraction rules, right? But it would become A over C plus 1, right? C over C is 1. So you can't just cancel the C and the C because A is also being divided by C. All right. And then the final property is our cross multiplication, which says that if A over B is equal to C over D, then I can move this D over to this side by multiplying, and I can move this B over to this side by multiplying. And we'll do more cross multiplication, but when we get there, we'll do a lot. Right. Any questions about that? No? Math. It's all math. Math rules. So, I think I had, let's do an exercise. Let's do 29 from this list here. Probably do another one too. Let you work on it for a little bit. Okay. So if we're doing, what was it? 3 over 10 plus 4 over 15. First thing you're going to check, right, is do I have a common denominator? In this case, no, I do not, right? So I have to fix that before I can keep going. So the easiest way that I find is, I'll show that this is a plus, is the way I just showed you, right? Where on this side, you're going to multiply by this over this, right? And then on this side, you're going to multiply by this over this, right? Turning it into ones. So what we get is we get 3 over 10, and then I'll just do it in another color to show you, times 15 over 15. And then plus 4 over 15 times 10 over 10. Right? Notice how we've just taken the bottom from one side and the bottom from the other side. I'm going to use those. This is not the least common denominator. The textbook talks about the least common denominator, and I prefer this method because it's a lot safer. right? If you're trying to find the least common denominator, so the smallest thing that divides both of these values, right? Could use that, but I like this way because at least if I do this every time, then I know it's going to work, right? And so now we're multiplying fractions, which means we can just multiply across, right? And so 3 times 15, I think is what, 45? And definitely use your calculator. Don't try to be a hero. I want you to use your calculator, right? You don't have to do math in your head because sometimes even when we think we're right, we're wrong. And so just use your calculator. I'm totally fine with that. I use my calculator.
Is it okay though to just go for the least common denominator if it's like if it's an obvious?
Oh yeah. If you're comfortable with the least common denominator, then that's great, right? But for me, when I'm showing my work, I'll do it this way. But if we get to the same value, right? Or at least when we plug it into the calculator, they're the same values, then you did it, right? So 45 over 150 plus 4 times 10 is 40 over 150. Now I've got that common denominator. And so 45 plus 40 is 85 over 150. An integer over an integer, just to tie back to the beginning, right? Now we've got this rational number. And you can use your calculator to see what it looks like. But for now, we'll just leave it as a fraction, right? Remember, if you convert it to a decimal, then you've got an approximation. So you'd have to use the squiggly equals. All right. Let's do, which one do you want to do? None of them? I'm leaning towards this one. This mumba jumba. Let's do it. 32B. I guess this was 29A. Let's do, oops, 32B says 2 over 5 plus 1/2 all over 1 over 10 plus 3 over 15. Give you guys some time to work through that. How did it go? So I'm going to start and just simplify the numerator, simplify the denominator, and then I'm going to do the multiplication, or sorry, the division. So in the numerator, I don't have a common denominator, so I'm going to need to do that. In the denominator, I don't have a common denominator, so I'm going to need to do that first. And so treating them separately, but working kind of side by side, I get 2/5 times 2/2 plus 1/2 times 5/5 all over, same thing here, 1/10 times 15/15, right? Just applying that same strategy that we used earlier, plus 3/15 times 10/10. Going through here, I get 4/10 plus 5/10, and scoot this down so it's not broken up over the pages, all divided by 15/150 plus 3 times 10 is 30/150. Now I can actually add these because I've got the same denominator. So I've got 4 plus 5 is 9/10 over 15 plus 30 is 45 over 150. Make sure that looks like a 9. Fraction over fraction, right? I always kind of in my mind or kind of, I do this, right? Because the move is to go like this. Yeah. And so we've got 9/10 times 150/45. And you guys have probably done it. What's 9 times 150? 1250? 350. Thank you. And then 10 times 45, I'm going to say is 450. And so we can leave it like that, right? That's our exact answer, or we can find the approximation using our calculator. Right? Maybe it turns into a whole number, I don't know. Doesn't matter. That's an answer. Right? All right. Any questions about those? No. So, just gonna do these in chunks. So, a set is a set of elements, typically numbers. And so the set of real numbers is all possible numbers. The set of integers is all whole numbers starting from 1 and going to positive infinity, right? So all of these are sets that we talked about earlier. The set of integers is from negative infinity going up by whole numbers through 0 all the way to positive infinity. Right? And so we can say things like something is in the set, right? And so I guess I shouldn't be blocking that so much. So if capital S, and typically we denote sets by capital letters. And so if the set S, then we can show that A, some element A, is in the set S. Right? And so what we do is we write A is in the set S. A is in the set S. So A is one of the elements that would be in that set. So that little kind of funny looking E it just says in the set. And especially as we're going through the beginning parts of this course, I'm going to try to introduce you to as many of these weird things that I can, because then as we see them throughout the course, they'll become more and more familiar, right? And so the earlier that we see them, it's going to feel like a lot in the beginning, probably. They changed their minds. Or maybe, I don't know. Right, so it's going to feel like a lot in the beginning, but we're going to keep using this stuff and it's going to keep coming up. And so things like this, A is in the set of S, right? It just says that A is an element in the set of S. Right? So we can say things like, well, Z, right, the set of integers, right? -3 is in the set of integers. And so we could say stuff like -3 is in the set Z, right? But pi is not an integer, so it's not in the set of Z. Right? So we can just put a slash through there. Often if we're talking about smaller sets, then we use this curly bracket notation, and we just list all the elements inside a set, inside those curly brackets. So here, this is called set notation. When we use those curly brackets. And it's just giving you a list. So here it's telling us that A is the set of the numbers 1, 2, 3, 4, 5, 6. Right? If we had to verbally describe this, right, it would be all positive integers that are less than 7. Right? We can translate that into the set 1, 2, 3, 4, 5, 6. If we want to get really, really fancy, right, we can use what's called set builder notation. Okay. The set A is all values of X such that, okay, so this vertical line says such that X is an integer, okay? So now, so X, we started out with X as can be any number, any real number. Now we've chiseled it down to, okay, well, X is actually just an integer, and more specifically, and X is between 0 and 7, not including 0 or 7. And so I've got that written out here, right, which is read as A is the set of all X such that X is an integer and X is between 0 and 7, not inclusive, right, or exclusive. Any questions about that? No. So from sets, we can do things like the union and the intersection of two sets. So let's assume that S and T, so capital S, capital T are sets. Then the union, we denote by this U. Right? Is the set that consists of all the elements that are in S or T, okay? Or is in both. Okay? The key here, where did I put it? I might not have written it out. The key here is that we've got this or, right? So the union, you can read as or. So S or T. Okay. Whereas the next step, the intersection, is this upside down U or a cap, right? And so here, probably didn't write very nicely. Too small. you can read that intersection as and, right? S and T. And so if you've got, and probably the easiest way to think about it, right, is you've got a Venn diagram. Do you guys remember like Venn diagrams? Circle in a circle, and then they've got some overlapping area, right? You can think of sets as, so set S is a circle, set T is a circle, and they may or may not have some overlap in there, right? And so S or T are just all the elements that are either in S or in T or in both, right? So it doesn't matter which circle it's in the set S or T. Whereas S and T, right, or the intersection, is only if it's in S and T. Right? So I'm gonna write this here. Oops. If we denote S by a circle and T by a circle, because it might be easier to think about it that way. Well, in this area, this area is S and T, right? The overlap. So it has to be in S and it has to be in T. It's missing some curly brackets. I don't know where they went. Okay. So, oh, and I guess we should talk about the empty set. It's a 0 with a line through it, right? So if that's typically how you write your zeros, because I know some people do write zeros with a line through it, now you want to be really careful because a 0 with a line through it actually means it's the empty set. It's the set that has nothing in it, right? Which is not 0 because 0 is actually, it would be something, right? So you want to be really careful. And so if we're talking about intervals, right? If we're on a number line, then we've got an interval from A to B, then we want to be careful of whether it's including or excluding those endpoints, right? And so if the endpoints are not included, right, then we can use these round brackets, right? And so here, A is less than X, which is less than B, right? And so here, endpoints are not included, whereas if we've got square brackets, then it's less than or equal to, right? And so it can be equal to that endpoint. So includes endpoints. Oops. Let's do, this says 41. So we'll do a few of these. We'll start with 41. Oops. Yeah. Weird. So we're told what the sets are, right? These are nice manageable sets, right? So now we can look at, well, what would A union B be? Remembering the union is just A or B. So now if there's some overlap, then you only write it once, but everything from both sets are included. Whereas if we look at A and B, right, it's only the overlap is that new set. So it shouldn't be too bad to just kind of work through all of these. But we'll start with 41 A and B. So A union B, nice. In A, I've got 1, 2, 3, 4, 5, 6, 7. In B, I've got 2, 4, 6, 8. So the only new one that I haven't covered by saying A was 8. So now, using those curly brackets, right, because A union B is another set, right? And so we use these curly brackets. So we've got 1, 2, 3, 4, 5, 6, 7, and 8. How about part B, if we want A and B? Yep, nice. 2, 4, and 6 are in both of the sets. What about, I was trying to find an empty set. There is no empty set. If I got rid of one of the 7s in A or C, there would be, right? Because what would the empty set be? If there were no elements in common, right, then the intersection of those two would be the empty set.
Right, in the 44 question, part B.
44 part B, A, B, oh, perfect. Good eye. 44B, A and B and C. So it has to be in all of those. I was sloppy when I was looking around. Thank you. So A and B and C. Well, we know A and B is 2, 4, 6. And so what we can do is we can say, well, we have to look for 2, 4, or 6 in C because there are none, right? There's no overlap across all 3. And so we would indicate this by just saying the empty set. Nice. Any questions? I want to at least finish 1.1. You'll see that the next page is 1.2. So I think I'm going to have to admit defeat and start those next day. But let's finish 1.1 here. On a graph, there's nothing really to do here. It's just a quick summary of, bless you, of what all these things would look like on a number line, right? Remembering that, okay, well, we've got this is called interval notation. So the interval from A to B. And so the notation here, the round brackets are just saying, well, I'm gonna exclude the endpoints. And to show that on a graph, you would make empty circles, right? To show that it goes to this point, but not including that point. And then if you're going up to that point, remember, we use the square brackets, right? To show that it's including those points. And then on your graph, right? Or on your number line, you're gonna use filled in dots. And then there's different combinations, right? Here for the third one down, we've got a square bracket around the A. So A is included, but a round bracket around the B, so B is not included, right? And so that's translated to a filled in circle at A, but an empty circle at B, right? So just work through those and just kind of make sure that you know what to do. And I'm going to put the exercise that I was going to make you do on here. But I'll leave it for you guys to work through later. Remember, I'll post these on Moodle, so don't worry. But I was going to make you do probably 1 or 2 or so of these. Probably starting with the first one, because that's how. It's always nice to start with the first one. Oh, all right. 47, -3 to 0. On a number line, right? Let's make a number line here. I do arrows in either direction because it continues. And then I'm going to put 0 over here, 1, even though I don't need it, -1, -2, -3. Starting at -3, right? This interval, it's not including, so I'm going to make an empty circle. Maybe I'll use a different color. An empty circle, and it goes to 0, but it does not include 0. There. So I make an empty circle. Okay. So you can do a couple of those. Do you guys remember the absolute value? Nice.
Sorry, I have a question.
Yes.
For the number line, for the closed circle and open circle, could you also do the brackets? Like I just always did. Brackets. Like if it doesn't include, then you do a round bracket. And, if it does include, then you put a square bracket over the. I guess the circles is kind of easy. Yeah, generally we use the circles. Okay. But I would totally know what you meant. Okay. So that's fine, right? But I am thinking for things like going into like keep going in calculus, it uses then we'll use the circles. Yeah. So, but at least if you've got the brackets down, then yeah, it's good. So the absolute value, remember, is just these vertical bars around some number A. Right? Those vertical bars essentially just tell you to drop the negative, right? But how it behaves is actually a piecewise function. So when we've got a function like this where it's split, right? So for some A's, it behaves like just A. And then for negative A's, so if A is less than 0, it's actually the negative of that number, right? Because here we're saying, well, if A is less than 0, well, that's a negative number, right? But if I take the negative of a negative, it becomes the positive version, right? And so that's how the absolute value behaves. But in practice, right, it just ends up being drop the negative, right? So just knowing that that's where it comes from, right? It's not just drop the negative and off you go. It's actually this piecewise function. So this is a piecewise function. We'll put the properties of the absolute value on here too. So again, this just outlines some properties. The key one being that the absolute value can actually get transferred. If you're multiplying inside, you're multiplying the absolute value of each of those terms. Okay? Same thing for division, right? You can split that absolute value up. However,
for addition and subtraction, it doesn't necessarily work the same way, right? And so all it says is that the absolute value of A plus B, we can't just do the absolute value of A plus the absolute value of B, because all we know is that it's going to be less than or equal to the absolute value of A plus the absolute value of B. And so, but that's a little bit for later. So just keeping in mind that you're allowed to transfer that absolute value only allowed to transfer the absolute value inside if we are multiplying or dividing. So it doesn't necessarily, it depends on A and B, right? Because if it's A, so if it's 3 plus -2, right, then it's not going to be the same. So, okay. We use the absolute value to find the distance between points on a real line, right? So if we've got 2 points, then taking the absolute value of that distance, the absolute value of the difference between those 2 points is the distance. That's what I meant to say. Notice that you take, so if A is before B, right? So if you're on this line, right? A and then B, so the interval from A to B, if you're trying to find the distance between those 2 points, what you end up doing is you take B minus A, right? So if I asked you what's the distance between 3 and 10, right? Then you would say, well, I need to do 10 minus 3, B minus A. And then depending on where I am on the number line, right, I'll just take the absolute value of it, and the absolute value is what gives me the distance. Like, so you can't have a negative distance. So I'll steal some problems here. Sneak in these absolute value problems, even though the distance problems are also going to be absolute value problems. But for those ones, we're going to do these. All right. Any questions? It's been a long day, a long class at least. There's so much knowledge that we need to kind of talk about before I can assume that you know it, right? So, so what I want you to do is go through and read the notes that I gave you for 1.2, and then over the weekend I'll post those notes for next week and just have a read through those. So you don't necessarily need to read the textbook because it can get long, right, and pretty boring, right? But if you look through all these fun facts, right, and then try to do those quizzes that I posted on WebAssign, right? If you're able to do those, then you're ahead of the curve, right? And so just make sure you read through, or kind of check through these, read up on things that you might not feel too comfortable about, and then we'll jump into just doing examples next day. Next day, we're back in that fun room. Not that this one's not fun, but we're over there. Right. All right, any questions?
Are those time questions that those marked?
I haven't just, I think I meant for them to be for marks, right? They're for marks. There, it's final. For assignment marks.
How do we check the answers?
Well, they're in the textbook, so I think if you're in the textbook, it'll just, you can just hit show.
Oh, okay.
Right, because I am just grabbing them from the back of the textbook. It's set up a little bit differently than how it is on the web page, but it should just say show answer, and so you don't have to like flip to the back or anything. Right? They've got that figured out at least. Yeah. But yeah, so all the answers will be there. You can always just text me too. All right. Any other questions before I close this up here? End this recording.